So where we are is section 12.1, which begins on page 768, and we are talking about complex numbers. Yes. No harder than it was when you did the same thing in Algebra 2. Okay. So what we're doing in this chapter, guys, is we're working with complex numbers. We're going to be solving equations by factoring, synthetic division, long polynomial division, recreating equations from the solutions, things of that nature. Again, you did this chapter essentially in Algebra 2, so this is the second time you are seeing it. So today we're just going to talk about complex numbers. And complex numbers, again, first of all, the symbol for the complex family of numbers is the C with the extra vertical line in it. So when you see that symbol, that stands for the complex numbers. And remember that the complex numbers are anything that can be written in the form of a plus bi, where I is equal to the square root of -1. And so this is what we use in order to work with and calculate negative square roots, or square roots of negative numbers. Remember, going back to the beginning of the year when we talked about all the different number families, remember we talked about the fact that, in fact, all of the real numbers, the imaginary numbers, the rational numbers, the counting numbers, all of those different numbers that we've been using all year are all part of this family. Any of those numbers can be written in the form of a plus bi, where I is the square root of -1 and a and b come from the set of real numbers. Okay? So for example, things like 7 minus 5i, 3 plus 2i, -1 plus 7i, etc. We also have things like 6. 6 is actually a complex number because it can be written how? 6 plus what? 0i. And imaginary numbers like 7i can be written as what? 0 plus 7i. So since they can be written exactly in this form, they belong to the family of complex numbers. Now, there are only a couple of different kinds of numbers that we have seen all year that do not fit into this family. Anybody know what those are? Anybody think of some numbers that don't fit into the complex number family that can't be written that way? Irrationals can be written that way. Because remember, a and b just come from the real numbers. So pi is really pi plus 0i. So irrationals fit in there. Any other ideas? Good idea, but not the right answer. I'm sorry? Yeah, matrices. Matrices are not complex numbers because they cannot be written in this a plus bi form where a and b come from the set of real numbers. Any other ideas? So that's one of them. And actually, polynomials are considered numbers as well. So even though the coefficients belong to the set of complex numbers, the polynomials themselves do not. All right. So when we're working with complex numbers, we always want to keep in mind that complex numbers should always be written in this form, this a plus bi form. And so a lot of the things that we're going to have to do is we're going to have to do things like this. They could give us, let's say, some number, we'll call it e. Let's say is 2 plus 3i, and some number f, which is defined to be -3 minus 6i. We'll just use those two. I just made these up. They're just random complex numbers. We can do things with complex numbers like add them. We could do e plus f, which means we have 2 plus 3i plus negative 3 minus 6i. And I functions like a variable where we just combine like terms and we get negative 1 minus 3i. So it works exactly the way you would expect. We could also subtract e minus f, which gives us 2 plus 3i. And notice when I substitute it, I'm using parentheses, because what are we going to have to do now? Distribute the negative. And what's the part that some of you are going to forget when it comes to test time? Distribute the negative. And then you combine your like terms. We can also multiply. And that would be 2 plus 3i times negative 3 minus 6i. What do you think we do here to multiply these together? FOIL. We're going to FOIL this out. So when we do first times first, we get negative 6. The outers give us minus 12i. The inners give us minus 9i. And what does last times last give us? Good. Negative 18i squared. I times I is I squared. So this now gives us negative 6 minus 21i minus 18i squared. But we are not finished with this, guys. It turns out that anytime we have a power of I other than 1, it can be simplified. Or above 1, it can be simplified. So, going back here, we know that I is equal to the square root of negative 1. What is I squared then going to be? Negative 1. Because when we square this, it pops the number on the inside out. Now, the question that pops up a lot of times is that if I is equal to the square root of negative 1, then shouldn't I squared be equal to the square root of negative 1 times the square root of negative 1? Which is the square root of negative 1 times negative 1. Isn't that the square root of positive 1? Right? Isn't that our property of radicals? That the square root of 2 times the square root of 3 is equal to the square root of 6? Isn't that true? So why is this not true? Yeah, what it is that this only works, guys, when we have non-negative numbers inside the square root. It's not really having to do with non-real numbers so much as it has to do with this property is only defined the square root of a times the square root of b equals the square root of ab so long as a and b are greater than or equal to 0. That's the way that property is defined. Well, if a and or b are not greater than or equal to 0, you cannot use that property. Okay? So that's why this does not become the square root of 1, which is 1. It's when you square this, you get the square root of negative 1 quantity squared. If you want to think about that, guys, the square root is really what power? 1/2. And then that whole thing is being squared. Well, when you raise something to a power to another power, what do you do with the powers? Multiply. What's 1/2 times 2? So that's really negative 1 to the first power, which is negative 1. Make sense? Okay, that we can do with a negative number inside, but this property we can only do with non-negative numbers on the inside. So that means that when we get down here, this is really negative 18 times what? Negative 1, which means it becomes what? Positive 18. So this really becomes negative 6 minus 21i plus 18. So what an I squared does is it just changes the sign of whatever number it's attached to, whatever its coefficient is. And then we can combine this further to get what? 12 minus 21i. Good. That's it. Now, because of this idea, guys, we can actually simplify all powers of I except for 0 and 1. So we know that I to the first power is just I. I squared we know is negative 1. I to the third power is going to really be I squared times I, which is negative 1 times I, which is negative I. So again, the power disappears. So anytime you run into I to the third power, it just becomes negative I. I to the fourth power is I squared times I squared. Well, that's negative 1 times negative 1. That's positive 1. So again, the power disappears. What about I to the fifth power? Well, I to the fifth power is really I to the fourth power times I, which is 1 times I, which is just I again. I to the sixth power is I to the fourth times I squared. It's 1 times negative 1 is negative 1. Do you guys see what starts happening here? We have this repeating. What do you think I to the seventh is going to be? Negative I. Because it's I to the fourth times I to the third. So the I to the fourth just becomes 1, and so in essence it drops out, and we just get whatever the other piece is. Okay? And so it turns out that this thing repeats in cycles of 4. I to the ninth would be the same as I to the fifth. I to the 10th would be the same as I to the sixth, etc. You're just multiplying by another I to the fourth power, which is just 1. Which means that we can now do things like I to the 267th power, and we can simplify it. Now, you can figure out, okay, where that fits in the cycle, but an easier way to do this, guys, is you do 267 divided by 4. How many times is 4 going to 26? That's 24. Subtract 27. How many times is 4 going to 27? 6. Which is 24. Subtract is 3. Remainder 3. What that means, guys, is that I to the 267th is I to the fourth power 66 times. So raised to the 66th times I to the third. Okay? My computer's having issues today. Having a nervous breakdown. Well, what does this guy equal to? 1. What's 1 to the 66th power? 1. So do you guys see that all of those I to the fourths disappear, and really this thing just lines up with I to the third power, which we know is negative I. So it turns out that I to the 267th power is just negative I. You guys see how that works? So what we're doing when we divide is that the quotient is telling us how many times we're going through the whole cycle. And once those are out of the way, this tells us what our power of I left over is, and then we can just simplify that. Now you have to be a little more careful with the negative version of that, I to the negative 267th, but I don't think we run into any of those. Okay. So we talked about adding, we talked about subtracting, we talked about multiplying, let's talk about dividing. So let me erase these. So e divided by f is 2 plus 3i over negative 3 minus 6i. In order to cancel something, guys, all 4 of these terms would have to cancel at the same time. We'd have to be able to factor something out of the top and factor something out of the bottom and have those somethings cancel. That doesn't occur here. So we can't cancel anything, but we also cannot leave it in this form. Why not? Right. We have an imaginary number in the denominator, which the issue with that is really what? It's a radical, right? Exactly. It's a square root. That I is a square root of negative 1. That means we have a square root in the denominator, which means we must rationalize this. Now, in order to rationalize this, what do we multiply by? The conjugate. Very good. What is the conjugate? What do we multiply by? Negative 3 plus 6i. On the top and bottom. That's the conjugate of the denominator. We need to multiply by the conjugate to really get rid of all the i's. And so the conjugate of negative 3 minus 6i is negative 3 plus 6i. The only thing that changes is the plus or minus in between the a and the b. Notice the a didn't become positive. It's just this sign that flips. Negative becomes positive. Positive becomes negative. What we now do is we now FOIL the top and we FOIL the bottom. So to FOIL the top, we end up with, well, we already know what we end up. No, I take that back. We don't, because that was a minus. So we have negative 6 plus 12i minus 9i plus 18i squared. And what does the plus 18i squared turn into? So this really becomes negative 18, and negative 18 and negative 6 makes negative 24. And then we have plus 3i. Everybody with me on the top? In the denominator, we also FOIL, which gives us 9 minus 18i plus 18i. Notice those cancel out. That's why we use the conjugate, so those would cancel out. Minus 36i squared, but what does this actually turn into? Plus 36, and 9 plus 36 is 45. Everybody with me so far? But we can't leave this in this form, guys, because we need to write it in a plus bi form, which means you break this into two separate fractions. And then you see if anything reduces. 3 goes into both of these. So we end up with negative 8 over 15. And then 3 goes into both of these, plus 1 over 15 times I. This is the proper way to write this answer. If you stop one step too early, you will lose a point or two on a quiz or test. So make sure you put it in that form and simplify it. So you use the conjugate. Now, something they're going to ask you to do, guys, is they're going to ask you to do other things with conjugates. For example, they could ask you to find this. E with this bar on top of it. We call that E bar. That means the conjugate of E. And technically, it's really the complex conjugate. Okay, as opposed to just the irrational conjugate. So the complex conjugate of E, since E is 2 plus 3i, what's the conjugate of 2 plus 3i going to be? 2 minus 3i. And so they can ask you to do things like find E bar plus F bar. So find the conjugate of E plus the conjugate of F. They can ask you to use the conjugate in all kinds of different problems, not just the rationalized denominators. So when you guys see a complex number with that bar going across the top of it, it means you need to take the conjugate of it first and then do whatever they want you to do. Make sense? So if we had E bar plus F bar, that would be 2 minus 3i plus negative 3 plus 6i, which would be negative 1 plus 3i. Okay, so it's adding, subtracting, multiplying, dividing, rationalizing, working with conjugates. And I do believe that the only other thing we need to talk about is working with radicals. So, what does the square root of negative 4 equal to? Not 4i, 2i. 2i. What happens when you take a square root of a negative number is the negative comes out first as an I. Comes out as an I. It doesn't stay inside as an I. An I on the inside would be the square root of the square root of negative 1. We don't have that. We just have the square root of negative 1. So that negative 1 comes out, leaving you just a 4 on the inside, and then you can break this down normally and look for pairs. So you have I times the square root of 2 plus 2. There's your pair that comes out, and you end up with 2i. What would the square root of negative 48 be? Well, what do you do first? Take the negative out as an I square root of 48, and then you break down 48, which is 16 times 3. That's 4 times 4 times 3. I really don't have to break it down any further than that because there's my pair that comes out. And so this would be 4I times the square root of 3. Okay? Questions about that? Okay. What about when we do things like this? The square root of negative 12 times the square root of negative 3. Does this become the square root of 36? Yes or no? No, why not? You can't use that property with numbers less than 0 on the inside. So what you have to do is simplify these separately. This comes out as an I. This becomes 2I times the square root of 3 times this comes out as an I square root of 3. Now to multiply these together, you multiply outside times outside. What is 2I times I? 2I squared. And what is square root of 3 times square root of 3? And so this then becomes 2I squared times 3, which is 6I squared. But what does the I squared turn into? Negative 1. So this becomes negative 6 is the correct answer. Whereas this, if this had been true, would have given us an answer of what? Positive 6, which is not correct. All right, questions about that? All right, guys, that's basically the section, I believe. I don't think there's anything else major that I haven't covered. So the homework assignment, and you have the rest of the period to work on it, which gives you about half an hour. And this should go very fast. Assignment number 53, we're up to, correct? No? Excuse me. 47? Oh, I'm sorry, excuse me, guys. I'm on the wrong page in my book. I apologize. Let's try this again. Packet was 47, so we're on assignment number 48 right now. I had my assignment book turned next week. That doesn't do us any good. Page 774, 775. And you guys are going to work on 3 through 57 trips. And I think we'll throw number 69 in as well. Let me double check and make sure I still like that problem. Yeah.